In this video, we will learn about heat. So, heat is defined as a form of energy which is transferred between object and surrounding and between object 1 and object 2 or between two objects by the virtue of existing of a temperature difference between them. Let's say the surrounding temperature is T, object 1 temperature is T1 and object 2 temperature is T2. Okay, so because the temperature of these all the three are different, so I can say that heat will get transferred whose temperature is lower or higher depending on that. Let us say if T1 temperature is more than T2, then the heat will transfer from T1 to T2. If T2 was more than T1, then heat would have transferred from T2 to T1, and similar is the case with surrounding and the object as well. We know that molecules of a gas are in a state of random motion. Okay, so even in liquids and solids, molecules are in a state of continuous vibration motion to and fro, like this. In solids and in liquid, vibrations are felt like this on a molecular level, while in gaseous, they are going anywhere like this. Okay, so about an equilibrium position, and thus they possess kinetic energy because we know anything which is moving possesses kinetic energy. Now, the heat energy of an object is aggregated sum of kinetic energy of its molecule possessed by them due to their random motion. Now, as the molecules are randomly moving, so I can say that they all possess kinetic energy. Let's say kinetic energy 1, kinetic energy 2, kinetic energy 3, and so on and so forth. So the sum of all these is what we say heat. So heat is nothing but aggregated sum of kinetic energy of its molecule possessed by them due to the random motion. Now, SI unit of heat is joule. The SI unit of heat is joule. Joule, and the symbol is J, as same as that of kinetic energy. However, calorie and kilocalorie, that is 1000 calories, is commonly used unit for the measurement of heat energy. Now, what is a calorie? So, it is the amount of heat energy required to rise 1 gram water's temperature through 1 degree Celsius. Okay, so let's say approximately from 14.5 degrees Celsius, if I am rising the temperature to 15.5 degrees Celsius of 1 gram water, then I can say that the amount of energy required or the heat energy required is our single calorie. So on calculation, it was found that it was 4.186 joule, or I can say approximately 4.2 joules. Okay. Now, what is a kilocalorie? So it is the amount of heat energy required to rise temperature of 1 kg of water by 1 degree Celsius. Let's say again from 14.5 degrees Celsius to 15.5 degrees Celsius, but this time of 1 kilo water in place of 1 gram of water. Okay, so this we calculate 1 kilocalorie came about 1000 calories, which is 4186 joules. Okay, now temperature. So temperature of an object is a relative measure of its hotness or coldness. Okay, now more appropriately, I can say that I can define temperature of an object as its thermal state, which would determine the direction of flow of heat from the object to another object which is in thermal contact with it. Let's say that my temperature relative to other person is different. I know that, let's say my temperature is T1 and another person temperature is T2. Now, if I touch that person and T2 is greater than T1, so relatively I can say that your temperature is more than mine. Okay. So in this particular case, the heat will get transferred from his to mine hand. Okay. Now, heat always flow from higher temperature to lower temperature, as I just said, from T2 to T1 in my case. Okay. Now, the two objects are said to be in thermal equilibrium when they both have the same temperature. Suppose that there's an object, so this is a box 1 and this is box 2. Both the box have T temperature, let's say 37 degrees Celsius. Now, as both have the same temperature, so there would be no transfer of heat from one object to another object, and the state is known as thermal equilibrium. Now, to measure the temperature of an object, we use a device known as thermometer. Okay. Now, the SI unit of temperature is Kelvin. Okay, with a K capital, but we commonly use degrees Celsius for measuring the temperature. Now the size of 1 degree temperature is same on both Celsius and Kelvin scale, but the 0 of the Celsius scale corresponds to 273 Kelvin scale. Okay, So I can say that T degree Celsius is equal to T plus 273 Kelvin. Okay, as on 0 degree Celsius there are 273 Kelvin temperature. Okay, however, the change, that is T2 minus T1, is equal on both Celsius and Kelvin scale. Okay, now let us suppose that 273 baseline temperature, let's say T1 temperature is 273, T2 temperature is 373 on a Kelvin scale, but on Celsius scale it would be 0 degree and 100 degree. So as you can see that T2 minus T1 is equal to 100 in both the cases. Okay, so this proves the line that the change in temperature is same on both the scales. I hope this topic is clear to you. Thank you.